Hello. In this video, I'm going over one of the problems I've recently thought up of, and it's a time analysis problem. So I go over a couple preliminaries here, as you can see, and just going through the video to mention something where I use big O notation, which by definition is describes a limiting behavior of a function with an argument where an argument tends toward a particular value. So I'm looking for a value where a number can be represented, a normal number can be represented by a graph like a circle, and when you lay out the circle in a line, it becomes more dense, like a inverse logarithmic relationship of like 4, for example, being approximately equal to log of n, or log 4 to the 28. And so I went to finite asymptotes, asymptotic study, and natural logarithms for the series, the type of series. And I've seen these series before, and they're very, very, very helpful in giving an example of higher order physics. So it showed that this image here, which I went back to another thing here in infinitesimal asymptotics, which are quite small or finite, mention a relationship between the series. So very fancy stuff, and I was working with a bunch of different factors and fields. I went into the tables for the big O notation, and I saw logarithms there because logarithms are important when used in asymptotes. So I went back and I realized, wow, this problem I made from Wolfram Alpha looks a lot like the image there. So I made a quick connection and had realized that it was quite interesting in that manner. You can see down at the bottom there is more of a redness to the gradient, and I would imagine that to be how you would imagine density to be if the graph were circular, like a circle. So I wanted to compute pi in there. So in the video here, I went over a bunch of different things that mentioned big O notation. So I used this big O notation, as we can see, just waiting for this to load. My screen, that is, for the video. And of c, which is a variable, and it computed that correctly, but it didn't take into the fact that it was having a sum of c for an expected value of the logarithm, or a map to like a 2n dimensional. So it didn't factor that in, and when you go along throughout the video, you'll see me work out the rest of this, but I'll kind of keep it brief in explanation. What I'm trying to solve for is a complex relationship between symmetries, geometry, logarithms, time analysis, and a bunch of other things. So I went down, saw that it followed along the same like sort of polylogarithmic scale, and interesting stuff there for a real and imaginary part. Very fascinating. It interpreted as the log squared of n, which I didn't really want because the 2n dimensional canonical system was not included for that. So though I'm not used to parity and some of these terms, I am looking into math more and figuring out what makes sense. So you can see I switched up something, and it inputted a different interpretation of the real and imaginary part, of course, I'm not going to be able to solve this myself, but it was just an intuitive thing that I came up with about the way of graphing it on a circle with the dot points. If you were to lay it out in a line, you would see that after it crosses 0 one time, it becomes more dense. So I went over this a couple times and tried to switch up my my ways of writing by adding another O for the Taylor series or the Maclaren series on this, but it didn't work still. And you can see it interpreted it as the same real and imaginary parts as before, with the same interpretation of log squared of n, which isn't what I was looking for originally when I came to the conclusion that it would be effective to demonstrate it as a number, like an expected value of the circle, which approaches another number that would be for an iteration or a repetition that goes over 0 2 times. Very interesting though, very fancy, and I'm not sure very well how to describe the relationship, but I have a bunch of papers that I wrote on it, and I think it's very fascinating. So I also did double or prime of the big O notation, and it just said that the derivative, or the prime of the derivative, the prime of the prime is the double prime, which doesn't help me very much. So I decided to get rid of the n and the 2n and then the other side as well. So after I go through here, I decide to mess around with the thing as I want it to be also highlighted that it took it as its own interpretation, so it didn't help very much that that was there. I decided to square it in the brackets and get rid of the other side there at the end, and of n, so the log of the sums, which seems like it would make sense, but it didn't put anything in. It said c is the log of the sum of c, which doesn't really help me because it just had a blank page, of course. It doesn't apply, it doesn't work. O, the big O notation normally implies asymptotes, so you can see asymptotic composition and decomposition and things like that, but I just couldn't figure out exactly what I was looking for, and it just kept on coming up with the wrong things, so it didn't work as well as I would hope. As I go into more of the video, I can maybe skip over. I'm not going to though. And then I went into one of my other graphs that I've actually done before, which shows some very floppy hyperbolic space. And quite interesting that it can graph those. I clicked on alternate forms to try to see if I could get closer to an understanding of the problem or the inquiry, and I chose 2 here for in a little bit after this. I chose 2 for 2n dimensions, but it didn't work, which would be the 4 pi 4 pi of 4n plus 1. So I went down again, and I don't know what I exactly did here, but I added the pi, which as a graphing software, kind of, it should apply it as a circular system, which would be intuitive, but I am very uncertain with it as an ability to graph it as a completely as a see. I was like looking for any solutions in Cartesian, and it just didn't show anything up. So the reason I wanted to look for it as a system was a circular system, or circular system, was because I thought it would be very helpful to show the density like it does when it has the analytic series, which for finite asymptotics or infinitesimal asymptotes, I showed the relation between the image and mine earlier, which was very helpful. That Wolfram kind of intuitively showed itself, and I thought that that was a connection enough to show that there was something going on with the time series and cylindrical systems, or cylindrical systems, not cylinders, circles, circular, not cylindrical, circular. I don't know why I kept on saying that, but I'm tired and trying to keep quiet. So, for my brother, by the way. Just went back and forth with this at the end of the video, pretty close to the end of this, and it just didn't really work in my favor, and it's fine. I'll probably find a solution in the future, but I think it's a very, very interesting real life example of the connections between different fields, and it's something that I'm willing to look into more, and very fascinating stuff. Thank you everyone for watching, and hopefully you have a wonderful day.